Hello everyone, welcome to Samadhan Life Science. Today's topic is hybridization and bonding. This is an important topic from your structure and bonding chapter for your GATE Excel exam. So let's start. So what is hybridization? So atoms form bonds by overlapping of orbitals, right? But sometimes the atomic orbitals mix together to form equivalent hybrid orbitals, and this is basically hybridization. So the number of hybrid orbitals is equal to the number of atomic orbitals mixing together. Okay, so now recall from our atomic structure chapter that atomic orbitals can have different kind of shapes, like s orbital is spherical, p orbital is dumbbell shaped with two lobes. But when they mix together the atomic orbitals, then the shapes and orientations can change to minimize the repulsion and maximize the stability, which gives us our molecular geometry. So now why hybridization happens, why we are considering this. So let's take an example. If carbon with this electronic configuration wants to form a bond with another atom, then it will use its valence electron, these four. But after forming the bond, the four bonds that carbon can form may be different, should be different in character because electrons are coming from two different orbitals. But in reality, if carbon form four bonds with similar atoms like in methane, all the four carbon-hydrogen bonds have similar properties like same bond length and same bond angles. So to explain this, we need hybridization. So hybridization is basically a model to explain the different shape and bond angles in the molecules. Now we can have different types of hybridization. Four of them we will discuss here. So the first one is sp hybridization, which is formed by overlapping of one s and one p. So two atomic orbitals are overlapping here to form this sp hybridization, which has a linear shape with bond angle 180 degrees. So let's take an example. If we take CO2, then this is the structure with sp hybridization and 180-degree bond angle CO2. Then let's go to second one, sp2, which is formed by overlapping of 1s and 2p orbitals. So total 3 orbitals. Okay. And the bond angle is 120 degree with a geometry trigonal planar. So if we take an example here, BF3, then this is trigonal planar. So all the molecules are in the same plane and the bond angle is 120 degree. Okay, let's take the next hybridization, sp3, formed by overlapping of 1s and 3p orbital. Example is methane, CH4. So this geometry is tetrahedral geometry. So if three hydrogen are here like that, one hydrogen is here. Okay, so this hydrogen, this carbon, this hydrogen, all three are in same plane, and then one hydrogen is towards you, one is towards me. So that is our tetrahedral geometry with a bond angle of 109.5 degrees. And the last one we will discuss here is sp3 dehybridization, overlapping of 1s, 3p and 1d orbital. So we can take example of PCl5. So central atom is phosphorus. C3 chlorines are here in trigonal geometry. So all of these are in same plane and the bond angle between them is 120 degree, same like BF3. Okay, but then these two extra chlorines are situated, one is above the plane, one is below the plane, and the bond angle between this above the plane chlorine or below the plane chlorine and in plane is 90 degree. So here two types of bond angles are involved. One is 90 degree, one is 120 degree. Okay. So from the all the hybridization, we can see that if we change the hybridization of the central molecule, the bond angle value changes. So in total, we can say that if we increase the S character, percentage of S character, then bond angles also increases. Okay, so this is important. You have to remember these bond angle values for your exam. So now let's take two examples from previous year question. So the first one is they are asking what are the hybridization and bond angle in BeCl2 and BF3. So BeCl2 we can draw like this linear structure and the hybridization is sp with a bond angle of 180 degree and BF3 we already discussed this. So this is sp2 hybridization with bond angle 120 degree. So here neither boron nor beryllium had any extra lone pairs on them. Okay, so the hybridization is simple. Now the second question, which is which following statement is correct regarding the bond angles in water and H2S? So for water and H2S, both has this bell structure. Sorry. So this is sulfur hydrogen, and both have here lone pairs. Okay, so these lone pairs will push the bond pairs away from them because the repulsion between lone pair is greater than repulsion between lone pair bond pair greater than repulsion between bond pair. But now for oxygen, oxygen is more electronegative. So it will pull all the electron towards itself more powerfully and the structure will be more compact. Okay, but for the sulfur, the lone pairs are more diffuse because sulfur is larger, right? So the lone pairs is more diffuse. So it will push the hydrogens away from it more. So this bond angle is 104.5 degree and this is around 92 degree. So between these four statements, bond angle is water is greater than that in H2S will be the correct answer. So I hope you understand the relation between hybridization and bond angle. Thank you for watching today. See you in the next video. Bye bye.